This video I'm going to talk about the multiplication strategy, and some of them already explained in PowerPoint. So if you want to know more about this, you can watch the PowerPoint first, and then you can listen to PowerPoint first and then come back to this video. So we talked about the multiplication math, how we can use this math to represent multiplication conceptually with chips, and how we can record this abstractly with abstract concept in the recording sheet. That's what we talked about there. And we also talk about repeated addition in here using base 10 block, and then a doubling strategy. And if you go to PowerPoint slide, they have more example in here. And also we talk about the area model and lattice method. Some of you may know the lattice method, and it's fine. But if you don't know lattice method, maybe first time it doesn't make sense to you, but once you understand how it works, it's going to be really easy. And a lot of kids love this because they don't need to deal with bigger numbers. All they need to know is multiplication fact. But from a mathematician perspective, this one doesn't talk about place value as well, so maybe not a best strategy per se in terms of place value, but it makes sense to them, and the kids love this method, and some of the textbooks introduce this method as a multiplication method. That's what I'm going to introduce in here. So area model was explained in PowerPoints. If you're not sure, just go back and check PowerPoints, but I want to show you lattice method because this one may need more practice for some students. So that's why I want to practice. If we know what it is, you may want to skip a couple minutes. But I want to talk about it first. So I want to show you this 14 times 56. So I'm going to draw a box first and divide it into fourths in here and make a diagonal line like this. And my number is 14 times 56. So one number goes on top, 1 and 4, not 10 and 5, 1 and 4. And the other number goes 5 and 6. And what I need to do is do all the multiplication. So 1 times 5 is 5. I'm going to put 0, 5. 4 times 5 is 20. I'm going to put 2, 0. 1 times 6 is 6. So I'm going to put 0, 6. 4 times 6 is 24, so I'm going to put 2, 4. So what I'm going to do now, I'm going to add these numbers by place value. So I mentioned that if we extend this line, it gives a little better picture in here. So this one is ones place, this one is tens place, this one is hundreds place, and this is thousandth place. So that's we are going to adding diagonally. So I'm going to add it this way. So 4 is 4 in ones place. And second is the tens place. So I'm going to have 6 plus 2, which is 60 plus 2, but 20. 60 plus 2 is 8. And I'm going to add this diagonally. 2 plus 5, which is 7. So my answer is 784. This is my answer in here. Okay? It's easy. So once they know how it works, how to draw squares and how to divide sections and how to add numbers, and kids love this because I just need to, multiply multiplication fact, and then I just add the one-digit numbers. They don't need to deal with the hundreds and thousands. Basically, they're hundreds place, but the process doesn't ask them to hundreds and thousands here. So that's what they can do. So this is one of the reasons why kids love this. But what if we have to carry the number? For example, the bigger number, pictured in here, bigger number I'm going to show you. Same thing, we have 3 digits. So I'm going to have I'm going to have a 3 box and 2 here. So I'm going to have draw line. So I'm going to put one number on top, 247, 247, and then 3 and 8. So all I need to do is multiply by single digit. So 7 times 3 is 21. So I put 2, 1. 4 times 3 is 12. So I'm going to put 1, 2. 2 times 3 is 6. I'm going to put 0, 6. And 2 times 8 is 16. So I'm going to put 1, 6. 4 times 8 is 32, so I'm going to put 32. And 7 times 8 is 56. I'm going to put 5, 6. And then what am I going to do? I'm going to extend the line a little bit so it's better to see the place value. And I'm going to add the numbers diagonally. So I'm going to add 6 here. It's going to be 6. 1 plus 5 plus 2 is 8. So here, I have 2 plus 2 plus 3 plus 6 is what? 13, but I don't write 13 here. I only write 3. And 2 plus 2 plus 3 plus 6 is 13. I'm going to put 3 here only. And I'm going to add 1 up here. So I'm going to add 1 plus 1 plus 1 plus 6, which is 9. So my number in thousands place is 9, hundredths place is 3, and tens place is 8, and then 6. So my answer is 9,386. Okay, so this is the bigger number. And some of the textbook using for the decimal, and this is why they love this one here, another reason. So let's say I want to do 24 and 7/10, and 3 and 8/10. So I change my number into decimal. So I do all the same places, but important part, the confusing part is that where does my decimal place go, right? So this one they can do is I'm gonna bring down this here and bring across this one and go diagonally, and this is going to be your decimal place. So I'm going to bring down this number, this decimal, and bring across this decimal and bring down diagonally. So my answer is going to be 93 and 86 hundredths. So they can easily use for the decimal number in here. So this is the lattice method. Okay, good. So now let's talk about next page, page 18. I want to talk about the Formal algorithm. Remember that we talked about the formal algorithm in addition and subtraction. They don't show all the steps, so kids can confuse because they don't see what's going on in the algorithm. Same thing in here. So I'm gonna show you one example here. I wanna show you 56 plus 14 times 14. This is times, and this is your student's work. This is 524. So my answer is 524. Is this correct? Is it correct? No? Why not? Because I have 2 lines here. It looks like, look at this. This is a formal algorithm, standard algorithm. Right? We are doing. They look exactly the same. I have 2 numbers up here, and 1 line, and 2 lines, and I have an answer. Why is not correct? What did I miss? So basically, when we are doing 2-digit times 2-digit number, how many times do we need to multiply? We need to multiply how many times? 4 times. According to distributive property, this number is 50 plus 6, and this number is 10 plus 4. So we have to multiply 4 times 6, 1 time, 4 times 5, 2 times, 1 times 6, another time, 1 times 5. So we are supposed to multiply 4 times. That's what we are trying to do. So formal algorithm looks like this. So we call them this, researchers call them this as buggy algorithm. You don't need to know the name, but this is a very typical mistake kids make in the classroom. So let's do traditional way. What do we do first? We do 4 times 6, 24. Do we write down 24? No? I want to write down 24. No? Why not? What do I do? What do I need to do? I write down only 4 and carry what? Carry 2 up here. And then I'm going to do 4 times 5 is 20. And plus 2 is going to be 22. What do we do now? What do we do with number 2? Maybe cross out? Why is that? because we are done with using this one, right? So we don't want to leave it to confuse kids. And what do we do next? Put 0? Where? Here? Why is that? Why do we put 0? What does this 0 mean here? I do nothing but have to put 0. Why is that? Because this is a placeholder. Now I move to my place value to tens place. That's why I need to have a place value holder. There's no number in ones place for this one because I'm working with the tens. That's why we put placeholder 0 here. So 10 plus 6, 10 times 6 is what? 60. And what do we do next? 1 times 5 is 5. I'm going to add them together. So my answer is 784. They look pretty similar, as you can see, but answers are different, right? So we have a lot of carrying and borrowing, carry and here, and then we don't say a place value. We do 4 times 5 is 20 plus 2, but this is actually 2 or 20. So this is 20, that's a place value. We are not doing 4 times 5. We are doing 4 times 50, which is 200, plus 20 is going to be 220. What about here? We are not doing 10 times 1 times 6. We are doing 10 times 6, which is 60. And 10 times 50, which is 500. We are not doing 1 times 5. This is not 1. This is not 5. If we use that one, we don't say place value. We don't observe the place value here. We have to keep the place value all the time in mathematics. So this one is an efficient way of doing it. But again, it hides some steps and kids cannot see what's going on. Every step we are doing, it doesn't show. Then can you try the standard algorithm? Extended algorithm like we did for addition? Why not? Let's try to do that. So I use this different paper so I can compare. So I'm gonna use this one so I can compare later. So this is expanded algorithm. So we have the same number, 56 times 14. So 56 is what? 50 plus 6 and 14 is 10 plus 4. So I know what I'm going to do is 4 times 6 is what? 24. So I'm going to write down 24. Why not? Now what do we do next? I did 4 times 6. I have to do 4 times 20. 50. So 4 times 50 is 200. And am I done? No, I have to do 10 times 6, which is 60. And also I need to do 10 times 50, which is 500. I'm going to add all the numbers. This is 224. This is 560. So I'm going to add all numbers together. So my answer 784, the same as the other one. So let's compare this. Let's compare this formal algorithm and extended algorithm here. So the expanded algorithm, we are showing 4 steps. We are supposed to do 4 times. 1 times 1, 1 times 10, 10 times 1, 10 times 10. That's what we did, and I show all the steps as I say it. As I say place value, I show all the steps. But this one hid some steps here, and actually this is the same as this. And this is the same as this. Do you see it? So, but this one does not show this process like this. This one does not show the process like this. But this is actually what we are doing. Kids need to see what's going on behind the algorithm. So the expanded algorithm help them to understand what's going on with the algorithm and what we need to do. We have to multiply 4 times. What if we have a 3-digit times 2-digit, like 324 times 14? Then how many times we need to multiply? We need to multiply 6 times, right? 1 times 1, 1 times 10, 1 times 100, 10 times 1, 10 times 10, 10 times 100, right? So that's why it can be very confusing for kids. So we need to show them all the process when you say it using place value, so kids can understand what we are doing when we do algorithm, when we are doing multiplication. Okay? Good. So this is all the explanation of multiplication strategy. So it's now time to practice, right? Practice help you learn. So there's a practice problem here. 45 times 27. I want you to practice with the area model lattice method, and expand the formal algorithm for all three for this number, 45 times 27. And if we are done, you are welcome to try the challenging one, because I'm wondering if it works for a bigger number. You can try. So 147 times 29 using the above three strategy. So please stop the video here and try to work on this problem. This is the best way to master the strategy. So especially we are new to the Monod method in here. It's a perfect time to practice your strategy, and you'll come back and show the answer. Sound good? Let's enjoy working on the problem.